Hi everyone, welcome to the Tech Seeking Human podcast. My name is Dave Anderson. I'm joined by Claire Palmer, and today we have Jana, who's the CEO of Nara Logics. Jana, welcome to the podcast.
Thank you. I'm happy to be here.
Maybe give us a bit of background as to who you are, your nerdiness, and what led you to start your company.
So I'm from Arkansas and it's lovely. I love Arkansas. I just couldn't live there anymore. And I got pulled out of Arkansas to go to Los Alamos, the National Laboratory. And so it's like ultimate nerd heaven and beautiful up in the mountains. It was absolutely lovely. And I met a boy there, and the boy got me to come to Boston.
Uh-oh. Is that boy still on the scene?
He's gone. He's not the one that I married, but I found the one that I married here. So we're here. But so I started out a research scientist. I left school. I didn't know what I was going to do after school. I was a math major, and my whole family was accountants. And so they were like, "How can you be a math major? What do you do with that?" And I ended up just sort of accidentally at Los Alamos because I didn't really know what a scientist was because I didn't have any of that in my, around me. And so that's when it was like, whoa, there's this whole different world. And my family was like, wow, mathematicians can do something. And they weren't dissing me at all. We never had it in our perspective. And so that's where I just got very lucky. I worked in neural nets and genetic algorithms out there, but I was really just solving a problem as a tool for me. And went to graduate school, and that was miserable. I went to Rensselaer Polytechnic, which I absolutely loved, but graduate school itself was a drag, and my boyfriend was here. And so my boyfriend from Los Alamos went to Yale and then got a job here in Boston. And that's how I came to Boston. I was like, wow, I love this place.
So you've got a long history in software development, right? So when did it progress from because obviously naturally we're talking a lot in our podcast about software, the evolution of software and the advent of AI. When did these things start to merge together, or when have they started to evolve? Like, what's going on in your world when you sort of summarize to people and say, well, this is my thinking around software development and AI?
Yeah, that's such a good question because for me, they were always merged. I was actually an AI person before I was a software engineer. I always said I was a programmer, and I just picked up whatever tools because I was a research scientist, right? So we're not really software engineers. We're just like, oh, grab this, try and make this work out. So I had early experience with AI, like I said, more than 30 years ago. And back then it was just the only reason you didn't use AI in business was really because it just took too much data and too much compute power. Out at Los Alamos, you were fine, right? Because we had all the supercomputer. That's why I started doing supercomputing, is so that I could actually do some of the compute that I needed to do. So I'd say, people have asked me like, why now? And it's really just because we have enough data and compute power. Compute has become a commodity, and some data has come a commodity. I don't think people totally understand what good data is and what good data for their applications are. So that's where there's still quite a bit of a challenge, but it's just that it's there. I worked at Lycos in the early days. This is in the mid 90s. And so we were doing NLP, of course, which it wouldn't qualify as the NLP that we know today for AI, but back then it was, so our definition of AI continues to change as computing has changed. But back to your question about software development. I mean, to me, we're treating them too separately. And we're not bringing them together. So we're not saying what are the good practices that we had with software and how do we leverage that with AI and machine learning. So we're not using what we learned and how to develop good software.
So it's the chicken and the egg. It's not even really true, because you're saying this one's quite clear cut. The AI came before the software programming, and software is just a way in which we can explore AI.
No, I was going to say, I do think it's actually the chicken and egg, because it's like,
It
why
is.
does it matter which one was
Okay.
was first, right? I mean, it's kind of like, both of them kind of were. I mean, obviously we had early computers that were using software, and we had early computers that were using data to kind of control and guide that software. So I would say that, it doesn't quite matter. What I usually say is the algorithm is the chicken, and the eggs are the data, and the bacon, which goes with chicken and eggs, the bacon is your objective function. So when we say, us Americans are obsessed with bacon, so we say bring home the bacon. So what's driving that? So that's really what I call the holy trinity of AI, is your algorithm, your data, and your objective function. And most people forget about the objective function, so they just run around trying to use an algorithm and find data for it, or they have data and they try and find an algorithm for it. And you really have to think of, what am I trying to do? And so, this is where people have gotten in trouble. Like, you have your Facebooks, and that's widely known for, well, their objective, or YouTube. There's some great stories about or studies about that, where their objective was engagement, and that objective really drives some bad things.
I failed at maths. I tried really, really hard. I struggled to turn on my graphic calculator, which I think was a Casio or a HP, so don't judge me. But for the average person, the objective, it's like the outcome. What are you trying to achieve? Is that how you would summarize the objective?
Yeah.
Okay.
Exactly. And it's, what do you value? What are you, and a lot of people don't realize it. They just say, oh, well, we were trying to get people to engage. And it's like, okay, well, what do you consider an engagement? Well, I consider them watching the next video, right? And like, what really grabbed them to do the next video, what got addictive, was taking them further down rabbit holes.
This is where because you got recommended to talk to, Trisha Wong recommended us to talk to you. And she asked, it's almost like she asks a lot of the why questions. It's like, so why are you doing this again? Sorry, like, is this data just so you get an outcome? And is this outcome actually going to help you in the end? And that's to your point, right? Like, so what? You get more engagements, but then could you be doing things that are morally corrupt as a result, just to drive more outcomes?
Losing profits by not having that objective in the first place. It was quite amazing to hear how many corporations didn't have an objective, and then they wondered why it didn't work, the algorithm, for instance. And yeah, so I think that's really interesting from that perspective as well, and I'd really love to hear what Nara Logics does to solve that in a way.
Oh, I'm so excited. Thank you for asking. As someone, I love this industry, so I'll talk to you guys all day about it. And please always ask more questions and say, well, explain this or that. I'm always happy to try. But so I was not a founder of Nara Logics. So they found me, and what they were looking for was someone who understood both the consumer side and enterprise, because they were trying to figure out what they were going to do with themselves. And they had a consumer app for recommending restaurants. But the real underlying technology was much more about learning from data, and we call them advisors now. So you can think of a restaurant recommender as an advisor, but really someone that's very much understanding you and your situation, which could also be the situation at a factory, right? And how is the output of my factory? So we have a customer who does process engineering. What's the quality of the output going to be based on data, right? And so when I saw it, it really took me back to my early days, just out of when I left research science. I joined a company, another MIT startup that worked in supply chain optimization. And so what we were doing was very simply, one of our applications, for example, was getting the best driver load assignment. So this driver should take this shipment for a customer. And that could be, there are 500 different reasons why you might want to assign somebody, everything from, this gets him home and he's due to get home, or this gets the shipment there on time, or the nearest person can't take that load because they have a gun and you can't take guns into New York. I mean, it's all of these kind of crazy things that you have to take into account when you're doing this. And it was just tons of fun. We had, just amazing stories. We would get notes from our customers when we'd come in the morning, hey, you guys got someone home to see their baby born.
Oh, wow.
Which you don't really think of when you think of supply chain optimization. So when I saw Nara, and so that was done with what was called expert systems, or what still is called expert systems, that are very much human tuned and driven. And when I saw Nara, what I got so excited about was that I said, these are self-building expert systems. So I don't have to go in as kind of an architect and design that kind of optimization of, well, how do I weigh, what getting someone home for their baby versus, driving an extra 100 miles to pick up a load, because all of those are paid miles. So you didn't have to kind of set up that rubric, if you will. That's what expert systems do. And so what I saw with Nara is that they were using data to build those rubrics, right? And so that's really kind of cool. And what was exciting to me, so that I understood because I had the experience there, and I get this. But the bigger thing is, to get AI adopted, from my experience, you really had to have why reasons. So we had to have, and we literally called them that at the optimization, the supply chain optimization company. We had what we called reason codes. And so we would actually say, this assignment is being made because low miles on the head haul, and getting a driver home for an emergency reason. And by the way, his truck's going to be near a maintenance spot, and that's great. So all of these things kind of add up. And so Nara also has that. So we have what we call transparent AI. So it's not a black box. You've heard about the black box problem with AI. Every answer that comes out, every piece of advice, if you will, because like I said, we help people build advisors, actually comes with a reason why, or not a reason, but it can be a bunch of reasons why.
Why are those reasons so important?
There's a few things. There is a lot of data that is, people talk about dirty data. I'm a little bit cautious about that, because I don't believe that it's dirty data. I just believe life is kind of dirty. And so, we work with a company that does maintenance information systems. And, that's what they came to us with. They said, gosh, we have this quality problem. Our customers, they're always fat fingering something. Well, it turns out that fat fingering isn't that big of a problem. And it's actually fairly easy to solve. I mean, there's some complexities there as to, should this product really, or this piece or part go with this thing that they're trying to repair or not. But sometimes it doesn't look like it should go, but it does, because they can't get the other part for 5 weeks, right? And so they have to make this part work. And so that's not really dirty data, that's just reality. And so there's a lot of things like that if you cleaned up your data, you're going to miss out on a lot of what happens in reality. And so to be able to understand what's actually happening with your data, having that transparency is important. So I often say to people, the explainability is a thing that they go, yeah, we need explainable AI, but it's not, it's more the understandability than the explainability. So that when they first launch their AI, why is it giving me these answers? Because we're natural skeptics. And even if we're told, hey, look, these algorithms, if they go into place, you are going to be so much better at your ordering. We're going to predict your supply chain so much better. It doesn't matter. It's proven that humans will naturally say, oh, but mine is an exception. My order that I'm trying to put in that you're telling me is the wrong order, that I should order 100 less. We will, even if we know that the computer's right 98% of the time and we're only right 89% of the time, we'll be like, yeah, but this time I'm right. And so that ability to see why, to kind of look at it and say, oh, actually the computer's taking into account something that I wasn't. Like I didn't even know that that other supplier was backed up or hadn't been delivering, or we didn't have this in our warehouse. To see what it's thinking, to validate what it's thinking, it's especially been shown if you can then interact with it. So if you can go in and say, oh, well, what if I was only ordering 50 instead of 100? Then would you say what I wanted? And see that different answer, that brings more credibility to the algorithm. So that's why I say it, explainability gets the billing, but I'd say it's more understandability that is the workhorse.
That's really cool, because that's for the first time the pennies dropped for me, because an explainable AI feels like it's telling you and you just go, okay, versus understanding means I need to understand it and I need to interpret it and then I can action it. Is that how you see that?
Yeah. And that's, so the people we worked with, so this is actually fascinating. So let me go back to my other, that software where I really I sort of learned this at Los Alamos because I worked with material scientists, and I would say you should configure they were films that they were making to conduct as well as metal. So plastic film. So I was basically trying to make plastic that conducted like metal, because lots of good things happen. They're easier to make, they're lighter weight, all that stuff. So I would say to the material scientists that I worked with, because I was a theoretician working in an applied group, and I would say to them, hey, think about this kind of arrangement of your film. And they look at me and say, why? And I'm like, well, it doesn't matter why, just do it, just the molecule. And they're like, yeah, but when you make things, it's kind of like there's variances, right? You have all these tolerances. And so they would ask me why. And then I was like, oh, that's really interesting. So I kind of learned that back then, and there were different methods. I would do sensitivity analysis, all of that. There's methods. Even I always say, even for the blackest box, there's night vision goggles. So anybody that tells you that you can't understand it because that's just kind of they don't actually really know. So sorry, I'm going on a little tangent there, but don't let people tell you that. It may take more compute power and you got to figure it out, but it is possible. Now, what I get really excited about is, like I said, really understanding that how do you explain this to people? And so one of the things that we did at the this expert system company that I worked at back in the mid 90s is we actually would give a test to their management, to what was called their load planners. So they're the people who actually, they were responsible for the shippers, so making sure that the loads got to the place on time, and to their driver managers. And driver managers, their objective was keep drivers, employed, because there's a lot of turnover in trucking. So that's their cost. Well, we would give them all this tests, like, what would you do what would you do if, and then it would come back and they'd always have different answers, right? Because so this goes back to the objective function. So the bacon for driver managers was keeping drivers happy. The bacon for load planners was keeping shippers happy. And the bacon for executives was making money for the company, right? But this quiz that we gave them would make it clear to each of them where they were making different trade-offs. Because again, we had explainable AI back then, and that's exactly what we're doing now. So when people come to us and, again, like when I saw that, I was like, this is what I used to do 20 years ago, and got very excited, because you have this ability to kind of go in and say, well, but what if I wanted to do this, or what if I wanted to do that, which goes back to the understandability piece of it. Did I go off on too much of a tangent?
No way, but all I could think of when you were explaining all of this was this tree, like how do you visualize this problem? Do you whiteboard? Do you pen and paper? Do you computer screen? Like, this must be this tree that goes on in your head. That's this maths formula that goes on. How do you do it?
Yeah, it is. You are so right. And we've had so many disagreements in the company because there's a lot of people that do want to visualize, and I've been kind of anti-visualization because it makes people's head explode. And so there is, sometimes we do build a decision tree just to kind of get what people are thinking out of it. And then we talk about how the way we're doing it, every single node in that tree could be the top of the tree at any point, right? So you're not having to start at one point, just like imagine being able to just pull it up and whoop, all of a sudden your tree looks totally different because you pop that up there. But what we've really done, and we have a paper on this, if anybody's interested, just reach out. We have a whole math paper. It's a nerd paper. But one of our brilliant team members said, actually, how you should really think of it is not really how our graph is laid out, particularly, but how the graph gets activated. And it's a bit more like, neural networks are often called tensor networks, and there's a flow across them. So you start with a certain node, like, I like this movie. What other movies might I like? Right. So you're kind of going through like this little flow path to figure out which movies on this other side. Well, the reality is all the movies are on the left side and all the movies are on the right hand side. That's not true in the graph itself, but you could imagine laying it out that way, right? Yep. Did I lose you, or are we okay?
So I'm just thinking about the movies that I like, but I'm doing my best to try and understand. Keep going though. So you don't. It's not a flow. You don't draw a flow.
We do. It's not unusual to do that, and when people read our paper, they understand it better. But what I often say is, we're this funky combination of a knowledge graph, which is, a knowledge graph, yep, which is just like Leonardo da Vinci was a painter and a sculptor, right? And was Italian. And so that's the knowledge about him and how he's connected. And a tensor network where there's a flow that optimizes for that. So I have this knowledge, but I also have this optimization that I can get that graph to act as a flow.
Does this go back to, I read this book about AI, and I'm not that full on with it, but in the original days of the AI, it had to follow like an if this then that type, like A or B, and then it became completely different, and it basically blew open. Am I on the right path here of like the two different tracks of where AI is going, and where are we?
So that if this then that was really what we called expert systems. So you're exactly right on, right? So that's what I was saying. We had to code kind of everything, and you could sort of code it with statistics, right? So my ifs and thens would change based on my input data and statistically how that might work out, or a cost function. Like I was saying, like it costs X amount to get a driver home to see his baby. Yep. And then what we're doing, like I said, is we're letting the machine figure that out. So that's what a neural network, and when they talk about deep learning, you're basically putting data in and letting it figure out what all the weights between connections are. And you're actually even not defining a node at that point. There's no node to say, get home and have a bonus for getting home, right? There isn't a node that says that. It's more like the brain is. Our brain doesn't really, our neurons aren't that way. Although you'll see there are like search for Halle Berry neuron and Jennifer Aniston neuron, and there have been shown that for certain overwhelmingly popular things, you will get a neuron that responds to it, which is fascinating. It's usually connections or networks of them.
I just can't get over the whole, like, it sounds ridiculously complex. Like it does. It sounds like it's not like you turn up, I've got a Mac Mini on the table. It's not like you turn up with a Mac Mini and you go, okay, Mr. CEO, what would you like to know? Let me apply my AI data scientist little Siri, and it's going to come up with an answer. Like where does it start? Where do you go in, and do you have these conversations? Do you have like CEOs going, these are the things we're trying to solve for, and then you bring your like ridiculous brain with all
Neuroscience.
your neuro
Neurons.
nerds who come in and these things all run around and then they go, here you go, Mr. CEO, we've got the answer for you, or Mrs. CEO, and here's your answer.
That is such a great question. And I'll tell you, the answer is really, it depends. So we definitely have some customers that come in and say, we want to predict the quality of the output of my factory, right? And that's what we want to do. And that's great. And that's totally fine. And we can go in and do that. And oftentimes it's more just a game of, do we have the right data? Like, I'll give you an example. We work with a company that works with veterinarians, and they wanted to advise veterinarians on what they should do in certain situations. And they had all of their customer support calls, and they said, can't the machine learn from that? And we did. We went in and we learned from that. So we had the data, and then we started giving answers. And then it goes back to that question of, oh, but it's wrong in this case. Well, why is it wrong? Oh, well, because you know what? We were on the phone with them and we didn't make a note that it was probably, if we recommended this, even though it's not in the data, it had to have been because this was the case and we just didn't make the note of it, right? So you have a lot of things like that you have most of what's in there, but you don't have the whole view of what's in there. So in that case, we backed up and we came up with kind of like, okay, what are all the primary cases? How could we learn from some of the data, not all of it, right? And then use all of the data to test on what we learned from, which was really fascinating because, like I said, it was different from what we thought. Now, what the other cool thing about that one, so we got to where we were, very high percentage of right for them. And the places that it wasn't right, the score, you could tell that we didn't even have confidence in what the answer was. So just with putting a threshold in, we went into production. And the great thing that came out of production in that case was the vet said, because we gave them multiple answers, often depending on where they were in the threshold. So we may give them 3 options, for example, that they were always coming up with one option. And they're like, okay, in this case, I should do X. And they liked having X, Y, and Z. It made them think differently, and it made them do different options. So that was fun to give them more options than they were used to and that they would have thought of. So they liked that. And the options that they hadn't thought of, they said it educated them. And so our customer was just like over the moon. Like, that was the best thing that we could tell them, besides getting the answer right, of course. It was that you just educated our customers, really. And that's what they got very excited about. So when they come in, do they have an objective? Yes. That objective was, we want to be able to put an advisor up when our specialty advisors, they have a whole group that answers the phone when a veterinarian calls. When our veterinarians, either we're backed up on the phone or we're just not there, we're not open. And so they were doing an advisor to expand their coverage, and convenience too, right? Not everybody wants to call. So if, one of the vets that we talked to, they're like, yeah, I get out of an emergency surgery at 2 a.m. I don't even want, even if they were open, I don't even want to call them on the phone. I just want to sit there on my phone, and get an answer like that in the quiet. And so, their objective was to expand basically their coverage. But what we ended up doing was doing that, but also educating their base. Mm. So they never came to us and said, can you help educate our base?
What advice do you give to people? Like, when you go in and you go, someone who's about to embark on an AI project and they're engaging you, what advice for, let's say it's a decent sized team, like not a small sort of company, a traditional company, I don't know. I mean, any industry, doesn't really matter. But what advice would you give to that team that are embarking on this project?
Yeah, that's such a great question. So there's a few different things that we say is, be prepared to change the way you're thinking. So if that customer had really stuck with, no, we're gonna, what is it like? If you beat the data enough, it will confess. So, it's like if they had just said, no, we have to, the only way we will learn is from our case, and not back up and be willing to do the cases, but also that kind of decision tree, overlay those two things. I think that's where, and so that's where you'd have a problem. So that's one of the things I always say is be willing to change your perspective and learn and understand when you have, that's again why I say it's not just the data or the algorithm, but also the objective. And anytime one of those changes, you need to consider changing the other. I don't say you have to, but you need to consider it. So that's one of the things that I say is pay attention to that holy trinity of AI and constantly be monitoring yourself. Did I change one of those? And if so, what impact did that have on the other two? And have open dialogues on it. One of the biggest problems with AI is that, and you brought this up earlier, it's often being led by the by data scientists or ML engineers, and they aren't software engineers. And so having the two together, because the software engineers are what is going to be the people who incorporate the AI into their software, and they're used to doing things like that. I mean, we've been integrating different bits of software for a long time. So how do I integrate that well? And also bringing those data scientists and ML engineers onto your product team. So, and again, we know how to do that. We've built product teams for a long, we used to suck at it, but we know that good product teams have a designer on them. We used to leave UX out of the whole thing. We used to just have, MRD back in my day, you had an MRD, a marketing requirement stock, and you basically threw that over the wall to the engineers with some pizza and, kept your fingers crossed that what came out was the product that they understood. But it often didn't, because you weren't interactively designing together between the product manager and the engineer and the UX. And then I always say you need the data person in there now. So you have these 4 people now that should be mixing it up, and that's what's going to make a great AI product.
It sounds to me like you have a pretty important role when it comes to consulting. So that'd have to be consulting and learning and cultural development. But is that a platform as well, like an algorithm, or do you work with other algorithms? Like how does it work?
Yeah, that's a great question. We're a startup and we like our customers, so I would say that we do. I would almost say counseling at times rather than consulting.
I thought you were going to say, do you want to do an off-the-record version for this? And you're just like, it's counseling. No, that's definitely on the record. Yeah, keep going.
No, my customers would say that too. They're like, no, that's one of the reasons why we love them, because they do this, and they I think part of the reason for that is we don't want to be consultants. Like, we don't want to track our time and do all of that. So our goal as a company is not services like that. We work very hard with our product that anytime we find ourselves doing work like that we automate it. So that's not what we want our revenue generation to be, which I think is why we kind of naturally counsel rather than consult. But I'd say that, we definitely help our customers with how do you structure for this? How do you think about it? What do you need in place? We have the prospect that I was talking to today came as a referral from another customer. And we told them, hey, look, until you have these things in place, it's probably not a good fit. That said, we're happy to talk to you as you go along and get those things in place. So if you want to call us every 2 months and kind of say, hey, we were thinking about this and we learned this and we saw this, we'll do that. And that for us just allows us to learn how organizations are going through this, learn what they're thinking about for their problems. And it's not a real heavy lift. I mean, we've seen, fortunately, we do have enough customers. We have enough customers that have gone into production. We've seen a lot of it. Although they sound a lot very different, they're often not really do. They all think that they're individual and all of that, but the same patterns are there, particularly when you're talking about, data, software,
Yeah.
objectives.
What are these customers getting? What's the value?
So it can be as direct as, we've increased conversion for customers, 2 to 7x. It can be that direct, and in terms of, average order value increases by 50% and conversion increases, like I said, by 3 to 5x. So it can be that direct. It can be reduced maintenance. So when I talk about something like that expert system, we've had several people that have replaced, hardwired expert systems. They were just getting too big to maintain. So factory, they had an expert system that was built with about 50 different parameters, but as they were adding sensors, right, because they're putting sensors all throughout their process, that was taking it up into the hundreds. And now I don't have to go in and recode. One of my healthcare customers, same kind of thing. They had a decision tree. COVID happens, you have to rewrite the entire decision tree. Right. And so that's one of the reasons why they went and said, okay, we have to have something different now. So you're seeing more people go that way, where they had decision trees, expert systems before, and now they need something that's more agile because things are changing. So the benefit there is just, I don't have to keep up with that, and I can better manage supply and demand. Yep. On something like that. And sometimes it's, hey, what the factory, so the factory problem was, I can do a narrow, so for them, it's process engineering. So if I deliver higher quality, that can be fine with my customer, but I paid more to do that because it just costs more. So what I really want to do is, I know what my customer spec of quality is, and I want to keep the tightest band of what I deliver to them. I can't go below, or I can't deliver it, but if I go higher, I'm paying more. So really keeping that within a certain threshold. Or I have a customer I mentioned, I think, with the maintenance MIS, and what the benefit for them really is better optimization between corrective and preventative maintenance. So I can help them detect when they should be doing preventative maintenance, like, change the oil every 5,000 miles. Yeah. We're all told that. Well, we all know that the way we drive our cars are so different that that's just a general rule. And for me, it may be better at 3,000 miles, and for you, it may be better at 8. Yeah. So that's the kind of thing that you want to do if you're running maintenance for your customers who have their heavy equipment, right? You really want to tailor it to how they're doing it. So you want to understand, for some people, it may be better to wait until it breaks because they're right near a depot and it's not going to take them any time to get that fixed. But someone who's out in the middle of nowhere that isn't going to that's going to be, having the tractor sit there for 4 months because they can't get the part in, that's different. And that's the kind of thing that you can optimize when you have AI. So some of it's operational, and people are more looking at what's the ROI. Well, some of the ROI that I'm doing there is I'm just saving engineers, right? So I used to, and I'm not like I'm replacing them. Everybody needs more engineers now because they're developing software, but I don't have to have 3 full-time engineers maintaining an expert system.
Are you seeing a trend in certain industries that are wanting to go forward with AI, or is it all different?
Yeah, it's not. I mean, there's definitely companies that are focused on different, retail is a big one, right? Because they're seeing that really direct ROI, and they like that. For us, because we have a more general platform, it's really much more people that are very serious about their digital transformation. So it's people that are saying, hey, I really do have to change. I've got to start thinking about, I'm not just digitizing that data, I'm going to start using it. And it's like the discussion I told you we were having today, where they hadn't really spent time. I mean, their CEO was embarrassed to tell me that a lot of their operations side was done on spreadsheets. And I said, well, remember that example that I gave you before, where I was saying we brought together data from the ERP system and from the CAD CAM system and from the product lifecycle management system? That was 3 systems for that problem. There were actually 12. The other 9 were Excel spreadsheets.
That's mind blowing. I just can't believe that still happens. And I'm not techie, but I'm surprised at that.
It's probably because they haven't taken that system approach. They haven't done what you've said, which is actually mapped out the journey. And I was actually going to mention it. They said you focus on the companies that are focused on digital transformation. I'm like, is there anyone out there not focused? But then it dawned on me, they might all be focused on it, but they don't really know what digital transformation is.
Yes, that's exactly it. They don't know. And to your point, do they come to me with a problem to solve? Usually they do, but most of the problems they don't know how to ask. And I understand that too. And I don't know their business, so I don't know, but I try and give them examples and talk to them about what data they have and what, another example is a company that we're talking to. They're not a customer yet, but they will be. Where they do supplies for their customers. So they manage basically the supply chain for their customers and have things ready for them. So I'll just use, let's pretend they do manufacture tractors. And so what they'll do is make sure that that every farm has a maintenance depot, if you will. It's not that. That's all done with spreadsheets.
So no collective intelligence. They can't learn from it's everyone working individually. This
is one of the reasons why I've said that Microsoft, if they could figure it out, is the dark horse in this whole AI thing. You have Google and you have Amazon, but Microsoft's that dark horse because they actually have the data. They don't think they've realized it yet. I've told them.
Really?
But they were kind of looking at me like, are you serious? Yeah, because they had me in to talk to them about Azure.
But isn't it a privacy? Isn't it a privacy thing? Like, because if you've got proprietary, because Microsoft's like, you're collecting all of it. And I do think they're a dark horse too, because I think they've got a lot of enterprise information. But also they're very hands off the data. That's the customer's data. But if the customer
that's great. I'm not trying to use it for other people. That's where I think we get into all these kinds of problems. I mean, use it for them. Like this is the customer, that customer that I was talking about, that it's all done on spreadsheets. It's like, they're not going to use it for other people. They're just using it for themselves.
But this is risky because then hi, my name's Dave. I'm from the New York Times. And so you're saying to me, Microsoft snooping in on people's data within the enterprise. Like, you can see where I'm going with this, right?
No, they're just building the tools for me to use it, right? As if I'm this company, make it easier for me to just ease into AI, right? That's what this isn't about. Microsoft sucking up that data. Now, I do know people that are worried about that. I know one of our healthcare customers was extraordinarily concerned about going to Google and Amazon, particularly when Amazon was in what's the name of that health thing that they were doing anyway? So they really thought they were going to, really go into that space. And so they felt more comfortable with Microsoft because Microsoft had been a enterprise software provider for a long time. So it's not really, I think that kind of thing, while I do think, that's the mentality, particularly of a Google, right? Because they've made money off of other people's data for a long time. Microsoft hasn't. You don't have to in this case. This is all just about enabling these people who own that data. It's their data. It's just about enabling them to use their own data.
Hey, finish this sentence for us. AI will ...
The sound effect.
Wow. Oh, I want a really good answer. Solve my calendaring problems.
There you go. Full circle.
I love it.
Not yet. Not according to you. You'll have to do it.
Yeah.
That was really bad. I'm sorry.
No, why not?
No, I really think I in all seriousness, that was a funny answer, or tried to be funny. I would say AI has the opportunity to make us happier. And there's really a specific reason why I'm saying that is because Nara actually means happy in Greek. And so it was actually named Happy Logics. So Nara Logics means happy logics. And so it's really our goal is that Claire talked about the engagement and customer engagement and happiness and fulfillment. That's really what we're trying to do. So I think AI will make us happier, even though it has it has some potential that to go the other way that we need to be careful about.
Absolutely brilliant.
Great answer.
Thank you so much for being on the podcast. We had a fantastic
Yes, thank you.
conversation.
It was a lot of fun. I really appreciate it.
Thanks, Jana.